For these little matrix cards, what you should have done is actually cut them all out, rearrange them, and then put them back into order again using row operation. So you could write the row operation on each card and basically go all the way to the end until you get to our reduced row echelon form. So we want to use Gauss-Jordan elimination. So if you did all of that, then you're checking back in to see that you're right and what the row operations are. So the very first card is writing it as an augmented matrix. So that's all that happened, was writing it as that augmented matrix. And so then from there, we have this new matrix where all they did, if you look really closely here, is they took row 1 and rewrote it as row 2 and row 2 as row 1. So the way we write that is row 1, double arrow, row 2. So that means that we interchange them. And the reason for that interchange was because we want to get a 1 here. So remember, overall, our big goal is to make our system have 1s in the diagonal and 0s below. That's if we want to use just Gaussian elimination, and that's called row echelon form. But if we want to reduce it all the way to make it really easy just to look at it and see our solution, we're going to go to reduced row echelon form, which is the process is called Gauss-Jordan elimination. So that's what we're working on right now with these cards. Okay, so the next card should be this guy. And what they did is they were turning this last guy into a 0. So remember, our goal is once we get the 1 in the upper corner, we want to try and get the 0s down below. So if I want to turn this into a 0, I need to figure out how can I make a 3 go away. Well, the only way to make 3 go away is if you subtract 3. So if you look, we can use the 1 in row 1 and turn that into a -3. So if I take -3 times row 1, add that to my third row, that will make this new third row. So let's see how that worked out. So -3 times row 1 was -3, -12, +6, -3. And I say we add that to the third row, 3, 2, 1, -7. And so let's see what happens. We're going to get a -10, a 7, -10, and 0, which is exactly what happened here. All right, so then we're going to move on to this next guy, and you can see the only difference is that this second row changed. They turned that into a 0. So to make that into a 0, let's do kind of the same thing. We're going to take -2 times row 1, add that row to row 2 to make my new row 2. So -2 times row 1, again, let's see our work. -2, -8, +4, -2. And we're going to add to that row 2, which was 2, -1, 5, -7. That makes 0, -9, 9, -9, which is exactly what we got here. All right, so then the next guy is going to be this. And what they did is once we end up with our column in the right way, then we can work and get some more 1s in our diagonal. So then we want the -9, you can see that that turned into a 1. So to make a -9 turn into a 1, so if you're trying to turn a number into a 1, you'll often use the row operation where you multiply by something. If you're going to make it into a 0, you multiply a different row by something and add, like we just did in the previous 2 operations. So if I want to make that 9 turn into a 1, well, I can multiply by -1/9. So I'm going to take -1/9 times row 2 to make my new row 2. So I write it as that fraction, but you can also think about it as dividing by 9. So if I take 0 divided by 9, that makes 0. -9 divided by -9 is the 1 we want. 9 divided by -9 is -1. -9 divided by -9 is +1. So that's how that row got formed. So then we're going to take that and head over to the next top column here. And so what happened here? Well, they got that -10 now into a 0. So to make -10 turn into a 0, we're going to need 10 times, well, the 1 we just came up with. So that's 10 times row 2. If we add that to row 3, that should make our new row 3. So let's write down what that looks like. 10 times row 2 would be 0, 10, negative 10, 10. Add that to row 3. That would be 0, negative 10, 7, negative 10. So we get 0, 0, negative 3, 0, which is exactly what we got right there. So now what's going on? We got our first column the way we want. We got this one almost. We're going to have to turn that into a 0, but it looks like they actually turned this into a 1 first. So remember, if we want to turn something into a 1, the fastest way is to multiply by something. So we're going to take row 3 and multiply it by negative 1/3, or divide by negative 3 if you like that better, to make my new row 3. So you can see that if I take 0 divided by 3, that's 0. 0 divided by 3 is another 0. Negative 3 divided by negative 3 is positive 1. 0 divided by 0 is 0. So what we have right now is done Gaussian elimination, and this is in row echelon form. So we could stop right here and rewrite each row as an equation and use back substitution. But we're going to keep going. We're going to do some more row operations to put it into the reduced row echelon form. So let's see what happened next. This negative 2 turned into a 0. So to make a negative 2 turn into a 0, that means we needed to do positive 2 times something. So if I take positive 2 times, I like to use the 1 in that column. So times row 3, I'm going to add that to row 1 to make my new row 1. So what that will look like is 2 times row 3 would be 0, 0, 2, 0. Add row 1 into that. That makes 1, 4, 0, 1, which you can see right there. So then next, they're going to turn that other negative 1 into a 0. So if I want negative 1 to turn into a 0, I'm going to multiply, well, positive 1 I already have in row 3. So I'm just going to add row 3 plus row 2 together to make my new row 2. And so row 3 again, 0, 0, 1, 0. Row 2, 0, 1, negative 1, 1. That'll be 0, 1, 0, 1, which is exactly what we have here. So we're almost done. Last thing we need to get rid of is a 4. So we need that 4 to become 0. So we're going to multiply again in that column, use the 1. So negative 4 times row 2 plus row 1 to make my new row 1. So negative 4 times row 2 would be 0, negative 4, 0, negative 4. Row 1 is 1, 4, 0, 1. We add those together, we get 1, 0, 0, negative 3, which is exactly what you see there. So our first equation, x equals negative 3, y equals 1, and z equals 1, we have solved. When z equals 0, oops, we have solved that system. So really the common procedure for this is if you have some matrix, the goal is to first make a 1 in that upper corner, then try and make zeros below that. Then you make the 1 in that middle, and then a 0 below that. Then you make your final 1. And each time to make the zeros, you use the 1 in that column that you had created. So to make that a 0, use the 1 up above. So then when I get to this corner 1 here, I want to make zeros above it. Again, I would use that 1, some multiple of that 1. And then last, put the 0 in here. So again, this is my goal, just trying to give you some order, but whatever works out the best. If you see things that can easily cancel and make your zeros, that's awesome. And that's solving the system with a matrix. Now these were 3 by 3. You could also do it with a 2 by 2 matrix. So just a little reminder how that would look. 1, 0, 0, 1 would be our goal at that point. Again, we would start with that corner diagonal, make the 0 below, make another 1, and then make that 0 above. Kind of follow the same process.